Welcome, function folks. Lesson 2.3, and we got one of these strange video lesson activity splits today. This video is taking up a 3-minute review, so hopefully you've tried it. But then after the 3-minute review, I'm going to stop and we'll have this in-class activity, which we'll do, and then there'll be another short video taking up what you're supposed to have learned in class, and then a homework example. So it'll be a little bit strange. You probably could watch this video before doing the activity, but probably to get the most out of this second video today, you should do the activity in class first. All right, well, let's get at the 3-minute review. This is basically taking up review of the big lesson we had last day, all these little bits and pieces about rational functions that we talked about. All right, first of all, find the X and Y-intercepts. So the idea here, the X and Y-intercepts happen when one of them is 0, we calculate the other one, right? So when X is 0, f at 0 is 3 times 0 plus 5 over 2 times 0 minus 1. That's 5 over minus 1. And probably most of you can do that without even showing a calculation. You could probably just fill in this one. The one that's maybe a little bit tougher for us is the x-intercept, or the roots when y is 0. So this was the y-intercept. Here's the x-intercept where we're going to do that calculation right here. X-intercept is when y equals 0. So when y is equal to 0, that's when this part's equal to 0. And we get a rational equation. One of the topics that we'll be covering in this unit is solving rational equations, but geez, we're doing it right here because I want to find out when this expression is equal to 0, and as long as this bottom part isn't 0, as long as 2x minus 1 is not equal to 0, I can multiply by that expression. And in fact, I know that it won't be equal to 0 because that's where there's an asymptote, right? That's going to be one of the things we talk about later. But here, if that's not 0, I can multiply by it. 0 times that is just 0 equals 3x plus 5. We kind of learned that last day that the x-intercepts happen when the top are 0. And then I can solve for that. X equals negative 5/3. Dandy. And then what's the next thing? Let me just grab that, copy that. I'm cheating on you a little bit there because I got all the room in the world now. State the vertical intercepts, or the vertical asymptotes. Well, remember, the vertical asymptote occurs when the bottom equals 0. Almost all the time, right? Remember that we did have that weird case last class where if there was a factor on the top and bottom that canceled, that the graph had a hole at that value, a half in this case. And we solved this up here already, x equals a half. But this wasn't one of those cases where the factors canceled, so the bottom, when it's equal to 0, gives me a vertical asymptote at x equals a half. That's the equation of that vertical line. Dandy. Next. Copy that, paste that in there. What's the next? Determine the behavior at f at x near the vertical asymptotes. Remember, we saw there was actually 2 ways of doing this. One was a numerical way. And this is the idea of as x gets close to a half from the left, where does where do the function values go? Like, where does the output go? Where does this thing go as x is getting close to a half but is lower? So what would be a value that's to the left of a half? Well, we don't have to deal with fractions. We can do decimals, right? Fraction is 0.5, so I might try 0.4, and then maybe 0.49 and 0.499. It's getting very close to a half, but is on the, I'm going to fix that up because that looks like 0.9. output is on the left. Okay, and you jam that into a calculator. Some of you are good at using your calculator, but in this expression goes 0.4 and 0.49 and 0.499 and so on, and I got this to be negative 31, negative 323, and negative 3,249. If you're having trouble putting that into your calculator, then just ask for some help in class. We can cover that in class. So therefore, when x goes to negative a half from the left, the outputs are going towards negative infinity, right? But we also have to do it from the other side. Very similar calculation, but what would be some values on the other side, the right of a half would be 0.6, and then getting closer to 0.5 from the right, bigger than 0.5 or bigger than a half, and I get, we've seen this now a couple of times, that when one's negative, the other one's positive. Not always, by the way. We have to be careful about this, but that's been a general pattern we've seen. So therefore, f at x goes to positive infinity. And so on the left, it goes down, and on the right of the vertical asymptote, it goes high. So I'm thinking of the picture now. Now I want to quick go over the other method, and that's my favorite method. And for the folks taking calculus, you kind of got to get good at this logic technique, by the way. The idea is I'm thinking of values going towards a half from the left, and so I'm thinking, well, what happens then to this expression? I got 3x minus 5 on the bottom, or on the top, and 2x minus 1 on the top. Well, notice that on the top, 3 times a half is, what is it, 3x plus 5, sorry about that. So 3 times a half is around 1.5, plus 5 is some positive number. Really, all we're interested in are positives and negatives. And on the bottom, when x is a little bit less than a half, that means this is a little bit less than 1. A little bit less than a half, 2x is a little bit less than 1. So a little bit less than 1 subtract 1 is going to be a small negative number. The idea, when I'm dividing by a decimal, a little tiny decimal, almost 0, almost undefined, that my answer is going to be positive infinity or negative infinity. But I have a positive divided by a negative divided by a negative then is a big negative. And so I think of that, showing that little logic in the margin is a good idea perhaps, but then I still get the same conclusion. Notice, do I care which way you do it? Do you do numerical way or logical way? Again, if you're a calculus kid, you're taking calculus next semester, you should get used to this logic business. That analysis, this type of analysis will help you in calculus. But I don't care. I think the logical way, once you get used to it, is a little bit faster, right? And then pick up the pace here, that the bottom's still a positive. Now this number's a little bit more than 1, and so this is going to be a teeny positive number, and so positive divided by a positive is a big positive, and I get the same conclusion. All right, what's D? Find the equation of the horizontal asymptote. Now this is actually what today's is all about. Now the way we did it last day was kind of a pain. It was actually kind of this numerical way, right? And I thought of x going towards positive infinity, and another calculation here, x going towards negative infinity, and the idea of what are my output values as x goes towards infinity? Well, 10, 100, 1,000, and I should make this really, really big so I get an idea about what's going on. And what is my output value, f at x? Well, you put it into your calculator. This one's 1.84. This one's 1.53. This one's 1.503. And, maybe you need to try another value, try 10,000 or 100,000 or a million, But it looks like f at x is going towards 1.5, and it's a little bit higher, so we could even put a little plus sign with that. But you know, what would be nice is if we didn't have to do this calculation, if there was some sort of fast way, and that's what today's lesson is all about. But let's not get ahead of ourselves. To negative infinity, to infinity and beyond. It's the Toy Story guide, right? Okay, what do we got here? F at x, this one's 1.19. Again, just clunking away at your calculator. 1.47. 1.497, and again, it looks like as x goes to negative infinity, the end behavior is this goes towards 1.5, but is a little bit lower. So now the last thing, it appears that the horizontal asymptote is y equals 1.5, although we would really like to be able to get to the point where we could just look at that and know it has a horizontal asymptote at 1.5, and we will today, I hope, in class investigation. The last little business is to put this together. Unfortunately, what's a little frustrating is all these calculations give us a pretty clear picture of what's going on in this graph, in this function. Give us an idea of intervals of increase and decrease and all that business, but not exact. We'll see that it'll be until calculus until we can get a full clear picture. So what do we got? We had the first calculation gave us X and Y-intercepts, X-intercept at negative 0, negative 5. So over here we had a point 0, negative 5. And a y-intercept of, oh sorry, the y-intercept was negative 5. This was negative 5/3. I'll move that a little bit closer so we can, negative 5/3. And then the y-intercept was negative 5 down here. And if you goof this up, don't worry about it. This is just a sketch. It doesn't have to be perfect. I'm not even going to put much scale on this. What was the next calculation? Was vertical asymptote at a half. All right, well, at a half, I'm going to put a vertical asymptote. And I don't care how far over this is. Around here, right? X equals a half. That's the vertical asymptote. So, what was next? The horizontal asymptote. Oh, the behavior near the vertical asymptote. That was part C. So, as x came towards half from the left, it went down to negative infinity. So as x approaches a half from the left, it goes to negative infinity. So we know it goes down like that. And same thing on the other side, it goes to positive infinity when x is on the right of a half. So it looks like this. Right? Horizontal asymptote at x equals 1.5, or y equals 1.5 rather. And I should be using a ruler here. You're using a ruler, right? And I know that when it goes to positive infinity, it's from above. And negative infinity from below. And notice, this is going to give us a pretty clear picture of this graph, because it's got to go through these points. What's going to happen here? It's going to do this, right? And because these points have to join up, nothing weird's going to happen. There were no other x-intercepts, so there we go. And so these dotted parts were kind of guessed. These parts were guessed. But the other parts were known. Pretty good. And don't be afraid when you're asked to sketch this, these graphs, to grab a graphing calculator and see what they look like. All right, that's it for the 3-minute review. I know it's a little longer than the 3-minute review, but you got the in-class investigation, and then we're going to come back and see if we can figure out how to get these horizontal asymptotes without having to do a big calculation. In fact, by the end of the period today, or tomorrow, whenever you're watching this video, you'll be able to look at the equation of a rational function and pick off the horizontal asymptote without any hassle. All right, and I'm going to pick that up after the in-class investigation in part 2 of today's.